Welcome everyone. This is lecture 2 for the Data Structures and Algorithms course. We're going to go over very basic Java syntax to begin with. After that, we'll talk about equals equals versus dot equals. Then, of course, move into getting some random ints or how to do imports for Java. After that, we'll very smallly touch on static versus non-static, but saving that more in depth later on. After that, we'll talk about using the scanner, the Java scanner, so you can get inputs from users. And then once we finish up with the talk, we'll go over a very simple problem using Java arrays. Now to begin with, the first thing we do is declare a variable called n, which is equal to 5. The two things to, of course, note when working with Java is you always have to have a declaration type, in this case an int, and then you always have to end a statement with a semicolon. Now that we have basic int doubles or anything of that nature, 5.0 would be a double, a boolean is true and false, and other things like that, feel free to look up on your own time. So now what we're going to do is go over different types of loops and other syntax for syntax management. So the first thing we're going to look at is the for loop. The way it's done is you have an initial expression, how long you're going to be doing it for, and how you update the expression. So you'd like to use this when you know exactly how many times you want to do something. So the case we're given here is we're going to have the for loop with the initial expression being I is equal to 0, I is less than n, which of course we set to 5, and we're incrementing one at a time. We do not add a semicolon here because that will end the statement. We're saying basically, if this expression holds true, we want to run what's in the body of that statement. In this case, we'd be printing out hello n times, which of course would be 5. The next thing we can talk about is the while loop. So the while loop basically just checks if an expression holds true for that iteration. So this is done when you're not really sure about what's going on, and you update the expression inside the body of the loop. So in this case, we have the unknown expression that we're trying to figure out is equal to 2. So we're saying while 2 is less than n, we're again going to be printing some stuff out, and then we're going to be updating the expression. If you do not update this, this will become an infinite loop going on forever and ever. So we'd always have to make sure to have that incrementation. And again, you'd want to have the semicolons at the end of the statement, not after the beginning of the loop. So this would be incorrect. After that, there is another type of loop, the do while loop. So this is done when you don't understand how long something will run, but it has to run at least one time. So in this example, we're going to be printing out hello at least once. And then we're going to be updating and checking whether or not we should continue. The difference between a while loop and a do while loop is a do while loop runs at minimum one time. And again, for the while and the do while, you need to increment until you get to the expression you're looking for. Because if you do not have that incrementation, it will be an infinite loop. Next, some basic stuff with if statements. Feel free to look up truth tables on true or false and true and false. But essentially, the way you have the if statement is, of course, if, open close brackets, test expression inside. And then you can also have else, where it would be everything other than this. So if we have true or false, it will default to true. And again, feel free to look up Boolean expressions later on. However, if we do true and false, notice and it has two ampersigns on it, as well as or had two or signs on it. true and false would default to false. So this code will never run. After that, a very simple thing about strings and other objects, some of them are called immutable. So what does it mean to be immutable? Well, they can be overwritten, however, they cannot be changed. So we're going to have a little thing here just to say we're going to be focusing on these for the output. So if we have string s, which is hello, that means that string s is always going to equal hello, and we cannot change it, we can only update it. So if we try to change it using s.concat, which means concatenate to the end, with word, most people would expect to have hello world. However, again, since it is immutable, we cannot have this. Instead, what we can do is print out hello, and now we're going to overwrite s. So this is how you can overwrite it instead of trying to change it. You can have s, and you can update it to be itself concatenated to world. And again, this is the same thing as plus equals. Again, it's just different syntax, and feel free to play around with it as you move forward in your Java career. So in this case, we'd print out hello world. Now moving a little bit deeper, we're going to talk about arrays. And basically, there are different ways to initialize an array. The first one is to add the information already in it, which can be shown here. Again, since this is Java, you're using the curly braces, not the brackets. The brackets are used to define the size of an array, or just to define the array. So in this case, we have A1, which is equal to 1, 2, 3. And then you have A2, which is empty, but it's allocated the size to 3. And then you can manually go in and you can update the individual entries. One way to, if you don't want to keep track of the number tree, you can do a2.length, and it'll be exactly the same. Moving on now, let's talk about the equal sign. So again, with strings and other objects, they are comparing based off content or comparing based off reference. So, for example, if we run this, even though S1 and S2 have the same string, they are being saved in different allocations of memory. Because here you're allocating a spot of memory for S2, and then you're allocating a spot of memory for S1. S2's allocation of memory and S1's allocation of memory are not the same. So when we try to compare the reference, that will be false. However, if we compare the content using dot equals, that will be true. So let's comment this out for a moment and run it. So we can see that the reference comparison using equals equals are not the same. However, if we compare the actual values using dot equals, it would be true, since the string is exactly the same. This can be also used for the equals equals on basic primitive data types, such as ints, booleans, and even doubles and floats. And again, just to reiterate, always have semicolons, and make sure that the open and close parentheses match up. Always important. So now that we have a good understanding of the basics of Java, what we're going to do is take a little step forward. So, of course, if you've used Python, there are different Python libraries. Similarly, there are Java libraries. One of the Java libraries we'll go over is the random. So the way you import Java libraries is by saying import and the location of where the library is located. In this case, it's in the Java class under the util class called random. And then of course we have our general main. And let's make a private static integer function called random int, which will say we want to have a specific bound. So between 0 and this level. The way that we're able to generate a random integer is by calling the random int class. And then you can see here that it has a specific bound set to it. And you can look up more information by simply Googling it. But you're not allowed to just call random.nextInt. You have to create a random object. So the way we create the random object is after we imported it, we initialize it. And in this case, we're just calling it random int. And we're setting it to a new random class, which again, we imported here. And now that's fine and dandy. Well, we're going to have this object now return the function that's predefined in the library called nextInt. And beside nextInt, they also have nextFloat, nextDouble, nextLong, and a whole bunch of other ones. Again, feel free to check these out later on. But in this case, the function just wants us to return a random integer between some bound. So in our main class now, we define a bound to be 5. And then we're going to say return to us a random integer between 0 and 5, and we'll print it out. So if we run our main, we should expect it to be between 0 and 5, and it's 4. Now, just for fun, let's run it again and see if another random number comes out. 1. Haha. So it works. Again, always remember, if you import the class, you always have to initialize it in order to get those function calls. And the name does not matter. We can name this to John, and then we can call john.nextInt. What matters is that you have the same name that you initialized it to, and then you can call the function. Great. So moving forward, we're going to talk a little bit about static and what that means, but it will be more important when we're talking about objects. So I'll just lightly go over it for now, and then we'll figure it out later on. So static basically means that the variables are shared inside between different classes. So in this case, we have our main function, and the first thing we notice is we can just call the function return 5. If we take out static, we have to initialize it, and it'll say here return 5 is non-static, cannot reference from a static context. So let's change it back. So we can very easily just add static and call that function. If it's not static, however, we do not have access to the things inside of it. So the way we get access is by first defining the class as a new class, and then we can call everything inside of it. And again, we'll talk more about this when we go over objects and class definitions, but for now, this is just a light touching of it. And we can see here, if we run it, we would get 5 and then 6, and there you go. Finally, we're going to go over the scanner before going to the example. So let's do the scanner. Well, again, we want to import a scanner. And what a scanner does is it reads input from the user. It can read input from a file or output to a file. And that's really cool and interesting because sometimes you're going to have to be working with users. So we have our main function. As previously stated with the random class, correspondingly with the scanner class, you'd want to implement a new scanner. And again, the name doesn't matter, but in this case, it would be easier to name it input so we know what it's doing. And then we define it as a new scanner, and we're setting it up to work with the system input. Don't forget the semicolons, don't forget the matching parentheses. So the first thing we want to do is let the user know that they need to enter something to continue. After that, what we're going to do is we're going to get the next input that they added in, and it doesn't even need to be next. It could be the next line or the next int. And again, this is all based on what you want to lead in. For now, we're just looking to do the next, which would be the whole line. And then after that, we're going to just say you're done. So if we run this, it runs and it says enter something to continue, and I'm going to type hello world, and then to send it in, I push enter, and we expect it to print out the next thing, which would be hello world. It's the next line. There we go. Next would be the first iteration. So hello world. There you go. We get hello world output. So that's how you would get input from the user. And again, I cannot stress enough that you need to have the scanner declared, or anything that you input, you need to initialize it. Now, let's go over a very small example that's working with arrays. So let's say that you don't really know what this mystery function does. Well, let's go through the code and see how everything should work out. The first thing we do is we initialize an array called A, and it has 10 data points inside of it, an array of 10 elements. These 10 elements at this point have not been initialized yet. But we want to initialize it, and the way we go about doing that is we can use a for loop, and we can say starting at position 0, less than 10, or just for fun, we can do a.length. And then we're going up by 1. So while I is less than a.length, what we're going to do is we're going to add into the position I its value. So at position 0, it will be a value of 0. At position 1, it'll be a value of 1, so on and so forth. And that's what we do here. We're accessing the array at array A at position I, and it's going to be equal to its index. And then we're going to print out the array. Everything else we'll hold on for a moment with. So we are adding into position 0 the value 0, 1, 2, 3, and so on, up to 9. Because even though it's a length of 10, we are starting at position 0 to 9. So after that, we run the mystery function, and we print the array first, and the array basically goes, let's get rid of that, from position 0 to the length, and it prints out the array at position I. One thing to note is that the input here does not need to equal the same words here. These are independent of each other. So if I made a second array called B, it would still, once it goes into this function, be considered array, and everything would work out the same. So these two variables, array A, does not need to be the same as the int array A here. So now that we've gotten that out of the way, let's go to this mystery function. So what this mystery function does is, starting at the 0th position, up to the length, so we're doing the whole array, so we can say for each element in the array, we're saying the index, so A at position I, which for the first instance would be A at position 0, which is equal to 0. It is equal to itself added onto itself. So basically you're doubling every element in the array. So if we call that function, Let's see if that's actually what happens. So we added, and then we're updating the index for position 0 to be position 0 to be the new updated position, which we set to be doublet. So at position 1, we have a value now of 2. Even though we added 1 with a value of 1, correspondingly, we added into position 2 the value of 2, and then when we ran the mystery function, we inputted 2, and we're getting 4 out now. Well, that's the basics for today's lecture. I hope you guys enjoyed it. A couple of references will be added to the link below. Have a nice day.